think we can already introduce Vignesh. So I'd like to introduce Vignesh before he sort of comes on stage. And in case you don't know, Vignesh is the founder of Time Campus, a bootstrap startup building a time management platform for users and businesses. Before becoming a solopreneur, he led a research and development team of 25 at Rumco Systems and also served there as a consultant for some time. He spends his free time blogging on Medium about a range of topics from time management and productivity to the open source ecosystem. So, GraphQL, Kubernetes, web components, architecture, and so on. So, now without any further delay, Vignesh, how's it going? It's nice to have you here today.
Hey Daniel, it's a good going actually. Apart from the COVID situation we have out here, so everything is great. So how are you?
I'm doing well. It's a little bit cold here in Berlin, but I'm really excited about some of the content that you have ready for us today.
Yeah, I'm excited as well. So actually already I'm excited after seeing all the people joining from throughout the world. So yeah, hi everyone.
Okay, so without any further delay, I give you the stage.
Sure. So let me in so that I can quickly get started with the session. So yeah. So I hope you are able to see my screen if I'm right. Okay. Yeah. So today's talk is going to be about all about GraphQL, right? So as Daniel mentioned, so we are going to talk about GraphQL A to Z. So actually, before starting off this session, I had a discussion with the Prisma team on how we should title this talk. We started off with the title GraphQL A to Z. Then I titled it Diving Deep into GraphQL. But then finally, I realized the fact is that it is not possible to cover A to Z or go deep into GraphQL in the 30 minutes I have, 30 to 45 minutes I have. So it's not possible to go deep. But what I will do in this session is probably take you through or walk you through a crash course of what GraphQL looks like, the entire ecosystem of tools out there. And once you are introduced to everything, probably you can read up more on that or read the blog series which I wrote. So let's get started with a quick introduction about myself. So myself, Vignesh. So as Daniel introduced, to all of you, I'm a solopreneur working on Time Campus, which is a time management platform for users and businesses. And I led an R&D team before. So my background is a full stack developer, and I used to work on DevOps as well, and quite a bit of machine learning. So I like to call myself a generalist. And this is what is Time Campus all about. So it's a time management platform. It's a bootstrap startup. We are launching soon in 2 months. So we have a lot to talk about. So without any of this introduction, so let's jump into GraphQL straight away. And for a context, so this is what the stack looks like. This is what we use at Time Campus. So if you see all of it is bleeding edge, I would call it a cloud native stack. And you see GraphQL right out here. So so it's basically a stack which is meant for solving the next generation problems in the most interesting way. So I will actually give you a context about all of this at the end of the session, but let's jump into GraphQL for now. So this series on GraphQL is what I published on Medium a month back, and it's probably about 66 minutes long. So, and we are going to probably shrink that into 30 to 45 minutes and probably give it to you in this session. So that's what we are going to do. And let's jump right into it. So what is GraphQL? And all this content which you see here in this slide is taken from GraphQL.js. So I have done nothing here. So I just put together all the amazing content out here. So you can basically see what GraphQL is in one slide. So GraphQL is a query language for APIs. So you have REST APIs, which is one way in which you can query data, do operations on data. So you can create records, update records. So you call it CRUD, right? So GraphQL is like a complement to REST, or rather I should say substitute to REST, not complement. So it basically, takes over from REST on all the challenges we had with REST. So from having to define every single endpoint for each and every operation we would want to do. For instance, for getting the user information, you would probably define an API. For getting the for creating a post, you would make an API. For getting the list of posts, you would make an API. So the list went on and on and on, and it became difficult to manage. And it's not just that problem. We had a ton of other problems because you had to make a ton of HTTP calls just to get information. So that's where GraphQL came into picture. And the more important part about GraphQL is it comes as I said, it takes over from the challenges with REST API. So let's quickly get into it. Probably you can understand more as we go on. So first step is ask exactly what you need. So if you want a user name or user information, or if you want to get a list of all your friends, that's exactly what you ask for, and that's exactly what you get. So if you see here, you just ask for a hero name, and what you get is a hero name. And the second part is you can get as many resources as possible in one request. So it's not necessary to make a single request for getting the user information, and another for posts, another for comments. So you can rather for instance, in this case, I can ask a hero name, I can ask his friends, and I can ask their names, and whatever, all the information, all the related information I want in a single query or mutation. So that's the power of GraphQL, that you reduce the n number of HTTP requests you make into one. So that's a amazing power. And the next important part is the type system itself. So GraphQL has a powerful type system which is also self-documenting. For instance, in case of REST API, I have to define a Swagger documentation to complement all the APIs which I have. So I have to define what my payload is going to look like, what my endpoints is going to look like, what are the types, and I have to define all the things, right? And it's not also enforcing. And then you have to go to the code and add validations to it. So you had to do a ton of things to get it strictly type compliant. And sometimes you might end up defining a Swagger documentation for a field to be string, and you might end up using the same field as integer. So it doesn't enforce a type. Swagger is meant for documenting the type. So but rather in case of GraphQL, we have a powerful type system which helps you not just document but also enforce types. So the validation won't allow you to query or do mutations if the type doesn't match. And if you see here, it's not just a type of a single element. So you have nested elements out here, and you have a powerful type system, and you navigate through. So there are basic types which GraphQL supports. One would be ID type, it's a special type to hold IDs. Another one would be string. Another one would be Boolean. Another one would be float, and then integer. So these are all the types which GraphQL supports in out of the box. But you can also add types to it. You can define your own scalar, you can define your own date time type, so you can define your own geo coordinate. So all of that power is left to you. So GraphQL tends to be minimalistic framework for all the people who are out there. So yeah, that's what GraphQL is all about. So as the website states, describe your data, ask for what you want, and get predictable results. So yeah, that's pretty much GraphQL. And let's dig deeper into this scenario. So in case of REST API, you will basically create multiple versions for multiple sets of data you're going to query, you're going to mutate. So each and everything will have its own versioning. So, but in case of GraphQL, what you have is a single endpoint. Slash GraphQL, and that is the only endpoint you use for doing all the operations. And if you want to add a new field, remove field, you just operate on the same field. You mark it as deprecated, you use directives to mark it as deprecated, and you just proceed. So I don't want to make this a GraphQL tutorial, so I will just stop here. So what you can do is you can also generate code, like you can generate TypeScript code from GraphQL schema. So because GraphQL is strongly typed, you can do a lot of powerful things with it. Like your editor can support IntelliSense, and you can generate, as I told you, the TypeScript types out of GraphQL types. So you can do almost all of it. And not just this, there is a powerful feature called introspection in GraphQL, where you can ask GraphQL about the schema, and it will return back all the response regarding the schema itself. So, and talking about powerful developer tools, so this is GraphIQL, and this is how it looks like. I'll just quickly skip through this video so that you probably get the picture. So you can basically ask for the title of all the films you have, the opening crawl, and you can just ask for the fields what you want, and you will get the response. So that's what GraphIQL looks like. So you ask for the title and opening crawl, and you get exactly that. So, and if you see here, you just did a control click and you can drill through the documentation. Okay, I'm going into the film type, and I'm going into all the basic types which it has. So that's the power of GraphQL. So it's not about just the schema itself. So GraphQL has a complete ecosystem around it. So there are a lot of developer tools out there which builds on top of GraphQL using the powerful features like introspection. You have other things like subscriptions. You have the powerful type system. So GraphQL does come with a lot of perks. But before we dig into more of GraphQL and the ecosystem, so let's quickly look at a history of how GraphQL has evolved over time. So it was initially, created at Facebook. So this page was open sourced by around 2015 with a just rough implementation written in JavaScript, which is GraphQL.js today. After that, people really identified that this would be the next birth of APIs. And that's due to a lot of factors. One more important thing about GraphQL is that it is protocol independent. What I mean by that is, so you don't have to worry about whether you use HTTP, RPC, or WebSockets or anything for that matter. So you can directly do all your operations using the protocol you already use. So that's all the power which GraphQL comes with. And recently, Facebook moved GraphQL to the GraphQL Foundation. I mean, they created a GraphQL Foundation and they pushed GraphQL project there. And now that is where even other projects like Data Loader and other projects live. And here we are today. And if you just look at the GraphQL system, the size of it, it is not possible to talk about all of it in this 30 to 45 minutes I have, but let's do some justice to the time we have and the tools and the ecosystem as a whole. So I don't want to go so deep into REST versus GraphQL, but let's quickly jump into it. So before this was the case, so you have backend for front end. So if you are using REST, this is how you would do backend for front ends. For instance, let's say that you have a mobile, you have a website, you have another client, you have what people ended up doing is, by the way, this is the architecture of Spotify, if I'm not wrong. So Spotify, what they did was they created a separate set of APIs for each and every client they are using. The reason was that they don't want to transmit all the information over the wire. So they didn't want to reuse the existing APIs because existing APIs tended to give a lot more information than what is actually needed. So what they rather did was they built out separate APIs for each and every client out there. And that's how they worked around, because REST didn't have any other solution because that's all they have, right? So they had to create multiple versions of APIs and maintain it in the server side, and that's what client used. So that's how they did backend for front ends. But today, what we can do with GraphQL is we can avoid this completely. And if you're using a mobile, you can just query for the data you need. If you're using a desktop, you can just query for the data you need. So that's how the tradition has changed from REST to GraphQL. So if you see here left and right, so for getting the same information, you need to do 3 requests in REST, and you can just do it all with 1 request in GraphQL. So you can minimize the number of requests you send over the wire, and you can directly get what you need. But now that I have talked about all of this, is GraphQL good for everything? So we do have REST as well, right? Which is a powerful competitor for GraphQL, especially given its simplicity. So sorry if I'm going too fast, but that's because we have a lot to cover. You might actually see me going through GraphQL A to Z. So yeah. So is GraphQL good for everything? And I would say no. The reason is because it depends on your use case and complexity. So let's say that you have a simple use case where all you want to do is get the latest let's say weather. So in such cases, if that's the single endpoint you have, so why bother putting up a boilerplate with GraphQL? Why add more complexity to the stack? So you can just define one endpoint, one REST endpoint to basically give you the latest weather for the respective location. So GraphQL might tend to be overcomplicated and will also have some more challenges, which I will be talking about as well. GraphQL does require a lot of boilerplate on the server side to get it set up properly, especially if you are using a federated or distributed architecture, distributed data graph. So by distributed data graph, what I mean is you split your schema into multiple microservices. So GraphQL comes up with all these problems, but yes, there are solutions available to all these problems, which I have outlined in my blog post. I won't go so deep into all of these, but there is n plus one problems where you make n number of requests plus one for getting a single for making a single GraphQL request. So, for instance, let's say that you want to get you want to get your friends and the list of posts each one of them made. So you will end up making n calls for your friends, n plus one calls, and then you have to again make a call to get their post and then that information. So it comes up with an n plus one problem. Then it doesn't have caching in place because you typically use a single endpoint, right? I mean, not typically, you use a single endpoint in GraphQL. So you don't have all of these HTTP caching in place with GraphQL, which you can do with REST. So because ultimately all the data is going to be sent through your payload, and you're going to use a single endpoint. So there is no point in caching the HTTP endpoint itself. But there are other ways you can cache the request. You can use persistent queries. So all of that can be done. So and then you have to worry about query complexity. So for instance, as I showed you, so you can have multiple levels of nesting in GraphQL, and there can be n levels of nesting. And as and when the number of levels of nesting increases, the complexity of the query increases, because you have to do a lot more, CPU complex tasks, right? And not just that, it's also about the computation you need to do to retrieve the data. So GraphQL talks about the business data graph, as I would say. By that, what I mean is, so you don't expose the technical complexities behind the scenes. So you might have named first name as first underscore name in your database, but that doesn't matter. What matters is what you want to expose to the clients from a business perspective. So if you think that, okay, I need to have a user, and he or she needs to have first name, last name, and all of the information related to it. So I just define the respective schema, and I define all the fields which I have corresponding to that respective schema without worrying about the technical things behind the scenes. I mean, I don't worry about what database I am using. I don't worry about what I have named, what the field name is behind the scenes. I don't worry about what data source, the number of data sources I have behind the scenes. So it abstracts a lot of things. But along with it comes the complexity as well, because you don't know how many queries you're going to make to get that respective information. Then you have complex boilerplates, as I told you. So yes, GraphQL provides a huge amount of power to the clients, but that does require a significant amount of work to be done on the server side. Yes, there are tools to make the job easier for you, but that doesn't mean that the complexity is reduced. It's just that it has been made easier for you. And then you can distribute data graphs. So if you are using a microservices architecture, you can put one data graph for every microservice. You can use Apollo Federation or schema stitching to basically help you split one data graph across multiple different microservices. So if you are working with multiple teams, so GraphQL to the client is always going to be a one schema or one endpoint, right? So you are not going to worry about, the client is not going to worry about what team maintains the respective data graph, or what the data, where the data is coming from. What they worry about is just getting the data from a single endpoint. But that comes with behind the scenes, that comes with a distributed architecture as well. So as you scale, as the number of teams increase, you need to distribute the data graph across multiple teams. So these were some of the technical problems I talked about. There are more which I have written in my blog, so better have a look at it before you jump right into GraphQL, because you don't want to go in the middle and get stuck, right? So better have a look out for all of these. But are all the problems technical in nature? Not all, because it needs GraphQL requires a change of thought from an organization perspective, and that's why people at Apollo have made a great website called principlegraphql.com, and you can have a look at it where they say what are the various things to keep in mind while you build a data graph architecture, distributed data graph architecture, which means, okay, worry about the business terminologies, not the underlying technical complexities. Take care of what do you say, a federated architecture, or have a distributed architecture. So they talk about all of these in the Principal GraphQL website. Better have a look out for it, where they will talk about the ways in which any business. So GraphQL is not just a tool for developers, but it's also a tool for the business and the product manager around. So because it gives a better sense into the data which your business collects. Almost every product collects data, right? So it is important for you to understand what the underlying structure of the data is, how you want to architect your data for the organization before you jump into GraphQL. So yeah, now let's talk about a fully typed GraphQL based architecture. By the way, before I go on further, so if you have any questions, so feel free to drop it down in YouTube chat, or send me a PM. So I will be glad to look at it. But in the interest of time, I'm moving forward. So let's talk about a fully typed architecture. As I told you, GraphQL is fully typed, right? So you have a strict schema in place. You have strict data types which you have to follow, and that is a great advantage because you get the power of IntelliSense validation. So it is better to have the compiler do all the work for you, or the editor do all the work for you, rather than you doing all the work. So that's where it really plays a major role, a fully typed architecture, because you as a user may make a mistake sending a string where the expected type is an int. But having a fully typed architecture will avoid such kind of mistakes. Not just this, it will also help you, give you things like autocomplete. So if you are, say, wanting to know what are the respective fields supported in user, rather than going to the documentation and looking up all the fields, you can just use the autocomplete which it provides. And there are a lot of other things as well which it supports. And it's not just for you, but also the tools you use with GraphQL. So as I told you, GraphQL provides introspection, so you can use introspection to do all of it. So that's why a fully typed architecture is really important, because you have an end-to-end validated system in place where you don't make these kind of silly mistakes, because one small type change can cause a myriad of failures across the stack. So you want to avoid that, and you want to make the developer experience great as well. So this is why Johannes from Prisma, CEO of Prisma, had actually talked about a fully typed architecture in one of the sessions. I have just took a snip of the same. So you have a front end, you have a GraphQL gateway where all the front end queries, and you have microservices, each with its own APIs. In this case, it is GraphQL APIs. It can be REST as well. And you have a DM, data management or data model in place, and you have a data access layer. So data access layer is where Prisma comes in, or GraphQL Mesh, which we'll be talking about, also comes in. So, or any ORM for that matter. So Prisma, GraphQL Mesh are ORMs. And you have a database. It can be anything. So in case of Prisma, it supports multiple databases. So, and same with GraphQL Mesh, it supports multiple data sources. So you can have multiple data sources underneath. And this is how what you see in right is how I have architected in Time Campus. So my database is dgraph, which is GraphQL native. I use GraphQL Mesh as my ORM. I use TypeScript and TypeScript CodeGen to do all the typing for me. So we'll talk about all of that as we go along. So now, before we get into the tools, let's quickly look at how you go about architecting a GraphQL app. So there are a few questions you need to ask. I won't go into all these details completely because we don't have time for this. But you need to see, okay, do you need monoliths or microservices? Do you need VMs, containers, or bare metal? All of these questions will also decide the way in which you would want GraphQL to be architected. Because, for instance, let's say you want monolith. If you're using a monolith for your architecture, then you don't need federation, you don't need schema stitching in GraphQL. So you just have you don't even need a GraphQL gateway. All you need to do is have a single GraphQL server and then just query that whenever you need it, or do mutations on that. By the way, by mutations, what I mean is if you are doing any operation except query, so creating, updating, deleting, those are all mutations. So yeah, by microservices, microservices do require a distributed architecture because you don't have a single point where you can query. Yes, you can have a single GraphQL gateway and then multiple microservices, each talking with gRPC. But yeah, it depends on how you architect, because ultimately that's what I'm trying to say. All these would decide the way in which you would want to architect GraphQL. So VM containers or bare metal, Kubernetes Mesos, Swarm or OpenStack, scaling needs, because the more you want to scale, the more you need to see, because let's say you have microservices running behind the scenes and you are using GraphQL for communicating between microservices. Now, GraphQL is protocol independent, right? So you can use GraphQL across gRPC, you can use GraphQL across HTTP. So the inter-microservice communication has to be decided based on the performance you expect out of your architecture. So if you want high performance, then it is better to go for things like gRPC or HTTP3, which is in the line. So yeah, so all of these are some things which you need to keep in mind before you start with GraphQL. So this is pretty much the checklist I use. And I have basically added all, I'm not going to read this out. I have added all of this in the blog which I have written. So you can go and refer that. But before selecting any tool for my architecture, so these are all the questions I ask. So does the tool solve my problem well? Does it have the right licensing model? Is it open source? Is it supported by the community? How many downloads it has? So all of these are some questions which you need to ask before you jump into GraphQL. Because once you choose a tool, yes, you can change the tool, but it is difficult to change the architecture. So you need to keep the architecture in check, and the tool can evolve over time. So ultimately, what I would suggest is pick a tool which is adaptable to change, which doesn't lock you in. So that would be a best start for you. So we have talked about all of this, but now starts the journey with the GraphQL ecosystem, and that's why I have this disclaimer in place. Better not get too overwhelmed by what GraphQL has to offer you, because it has a lot to offer you. So let's quickly jump into it. So the first one would be VS Code itself. I'm not going to talk about VS Code, don't worry. I know all of you are developers, so you use VS Code every day, but GraphQL is one of the powerful extensions. So VS Code GraphQL, Apollo GraphQL, these kinds of extensions do provide powerful IntelliSense support, code navigation support. They provide, configuration. So in case you are using VS Code GraphQL, you can also execute queries and mutations directly from GraphQL. Directly from VS Code. So you can do all of that. And the reason why I have put VS Code at the first is because that's pretty much where we developers live and breathe, right? Okay, you might be using a different editor, maybe Atom or something else, but yeah. So what I'm trying to say is VS Code would be the first platform, and all these extensions are already available. So for instance, you can prettify your GraphQL schema using Prettier. So you can have linting rules in place using GraphQL ESLint. So VS Code GraphQL can basically provide you all of these autocomplete and everything. So yeah, that's VS Code for you. So now the next thing which you need, important thing which you need is, so if you are using GraphQL and all the tools and ecosystem around it, you need a way to configure your schemas underneath. So you need to you need a way to define, okay, where does your schema lie? So what are the various ways in which where does my documents lie? Where does my fragments lie? So what are the ways in which I want to use GraphQL? Like, do I want to generate TypeScript code out of it? Do I want to probably use it in a modular fashion? So all these configurations will be basically done in GraphQL config. It's not a norm, so you can use your own configuration to do it. But the reason GraphQL config really shines is because you get a single tool or a single place where you can specify all the GraphQL configuration, because all the tools which build around GraphQL will need the same information, almost the same information, to identify or provide features like autocomplete or anything for that matter. For instance, unless any tool knows your schema, either through introspection or by directly specifying the GraphQL file, they won't be able to provide the powerful features around GraphQL which they are providing today. So that's where you get all the data types, right? So GraphQL config is like a single way to provide config for all the tools around GraphQL. So this is pretty much one way to specify, where I have said, okay, this is the schema I need. I have specified the wildcard. So I want to use GraphQL code gen, which means that I want to generate TypeScript types out of GraphQL. So I have said that, okay, generate the types for me and use all these plugins to generate all the types. So this is what I mentioned, and you can specify multiple projects. And for instance, VS Code GraphQL uses GraphQL config to do all of its powerful stuff. So VS Code GraphQL is one of the tools which has been now donated to the GraphQL org. It was made in Prisma initially, so, and they donated it to GraphQL Foundation. It's a really powerful tool. It just needs a bit more maintainership from the community, but it's really amazing. So you can say, okay, this is all the type I have. So it will provide you linting. It will provide you, schema highlighting or syntax highlighting, code navigation, and all of that, autocompletes and everything. So now coming to the next tool in the ecosystem. So I understand I'm taking you through all of these tools. The main reason is to explore all these tools so that you can fit them right where it is needed to be fit. So in a typical workflow, what you have is you define your schema, a GraphQL schema to define your data graph. So once that is done, so you basically say, okay, these are all the operations I want to perform. So you define the resolvers, you define your GraphQL server, you also define the rules you want in place so that you can establish consistency among multiple developers in multiple teams. So you need to do all of these to get a proper GraphQL architecture in place, right? That's where you need all these tools. So next would be GraphQL ESLint. So it's a new tool from the Guild. GraphQL config was also from the Guild. And what GraphQL ESLint does is it basically, it's a plugin for ESLint where you can define all the various rules or conventions which all the people must follow to when they are defining GraphQL schemas or when they're defining queries or mutations, so that you have consistency. Or even if you don't follow consistency, there is a tool watching out for all of this. So you can say, for instance, you can specify that all the operations must have a query name or mutation name. So you have no anonymous operation, require deprecation reason. For instance, you can deprecate a field without even giving any reason on why it is deprecated. So you have to be providing a deprecation reason, otherwise throw an error. So you can run all these rules through GraphQL ESLint. Next comes GraphQL Inspector. So GraphQL Inspector is where you assume that you have set up a GraphQL schema, you have defined the queries, mutations, but now you want to understand how many operations actually use that respective field from the schema. I mean, I had defined this field in the schema, but am I actually using it? That's where you have GraphQL Inspector helping you, like saying it will help you with coverage, and it will also help you with similarity. For instance, if you have similar operations, a lot of duplicates, so it uses the name to find out similar duplicates. So you can remove it if you are repeating the same field multiple times, or same operation multiple times. So and GraphQL Inspector can be run as a GitHub app as well as a in your own CLI. So there are multiple ways to run GraphQL Inspector. So in case, let's say that you want to send a pull request and you want to make sure that all the schema is validated, it follows all the coverage rules. So you can do it all through GraphQL Inspector. And then I've added TypeScript as well to the stack, because now all the tools I'm going to talk about from now will actually use TypeScript as a base, because TypeScript is a powerful tooling from Microsoft, and you might be already using it already. So I don't want to talk so much about it, but like GraphQL, it provides a strongly typed system for all the editors and plugins to use, and the developers' life is also made more easy. So you have IntelliSense, you have powerful type system, you have syntax validations, and you can code in the bleeding edge JavaScript syntax without worrying about the compatibility. You can do a lot of other stuff with TypeScript, which I can't cover in this session. And in fact, if I'm not wrong, there is a TypeScript Berlin meetup as well, so you can probably join that meetup group as well if you want. So next is GraphQL Helix. So I don't know if you would have heard about it. So a lot of people use Express GraphQL or Apollo Server for the GraphQL servers, but GraphQL Helix is a new entrant in this area, where it's a GraphQL server basically, but a modular GraphQL server. So you don't have to worry about all the complexities behind the scenes. Rather, you can just use those features which you want from GraphQL. For instance, let's say that you are not using Apollo Federation. You don't want your Apollo server to also include all the code related to Federation, right? So and not just that. So let's say that you are not using the Apollo stack itself. So but Apollo server will add all the boilerplate as well, because it needs to work with the suite of Apollo tools. And not just this, even if you're using other GraphQL servers for that matter, be it Mercurius, be it Express GraphQL, they come with all the features inbuilt. So, but what this does is it comes with just GraphQL JS as a dependencies, and it works across multiple frameworks. It doesn't, Express GraphQL works only with Express, right? So, if you want to use with some other framework, you need to watch out for some other GraphQL server. So this works across multiple frameworks, is modular, and you can scale as you go. It supports all the bleeding edge things like subscriptions, live queries. You have support for all of the things which you have in GraphQL, and it has only GraphQL JS has the dependency. Next tool in the stack which you're going to look at is GraphQL CodeGen. So what GraphQL CodeGen essentially does is, based on your GraphQL schema, it helps you generate all the TypeScript types out of GraphQL schema. So it essentially helps you write TypeScript code without having to define all the types yourself. So if you're working on your TypeScript code, you pretty much use typing, right? So interfaces, classes, you define types. So rather than that, since you have already defined all of that in your data graph, which is your GraphQL schema, you can use GraphQL CodeGen to generate all the other things for you from there. So GraphQL modules. So if you are using a microservices architecture, it's pretty much evident that you want a modular architecture. But even if you are not using microservices architecture, you might want code isolation. Today people talk about mono repos, right? So you want to have single repository with multiple packages. So and it can be a monolith as well. And if you're using a monolith, still there is nothing wrong in splitting the code. In fact, it is highly recommended that you split code within the monolith, so that later if you want to transition to a microservices architecture, you can. So this is where GraphQL modules really help, where it splits your application into modular structures, with each having its own schema, with each having its own set of resolvers and typings. So this way, even if you want to share this module with some other module, you can do it. It supports dependency injection, so you can do that as well. So GraphQL module is a way to split your GraphQL server, single GraphQL server, into multiple modules. So yeah, and this is pretty much how you use it. So for instance, if you want to, let's say, get a typing for your context, you can do that through GraphQL modules. If you want to, let's say, get the provider. So the classes are called providers because it provides a lot of types for you, a lot of functions for you. You get the provider and you do a lot of operations on the providers. So this is how a single module looks like. For instance, I just defined the resolvers which are related to this module. So I don't want to have a single file with huge number of resolvers as I scale the app, right? So it helps you split your apps into multiple chunks. Then comes GraphQL Mesh. So GraphQL Mesh is pretty interesting because it helps you leverage GraphQL without even having to transition all the code behind the scenes to GraphQL. For instance, you might be running gRPC code behind the scene, or you might be using REST APIs already behind the scenes, or you might be using an SQL database or even queues. you can just put GraphQL mesh on top of it. So it will act as an ORM or an abstraction on top, and GraphQL mesh will take care of the GraphQL part of it. So it has an execution engine as well. So once you define or it defines the GraphQL schema automatically based on the architecture behind the scenes, and you can modify that as well with configurations. And once you do that, it basically takes care of distributing the operations, queries, and mutations across multiple such services. So there are a lot of tools like this. I don't want to go so deep into it. GraphQL tools you use for doing things like schema stitching. You use it for other operations behind the scenes. Then type document node you have for typing all your queries and mutations on the client side. So in case you want to use let's say a respective you want to do a respective operation on the client side, all you do is you just define a respective type and you define the variables, you get IntelliSense for that. So yeah, basically you can generate all the documents out of existing schema and your client can basically query that. dgraph is a GraphQL native graph database which I use in Time Campus. So that's something which I had a talk or meetup about dgraph before, so you can check that out for more information. GraphIQL is the IDE I showed earlier, which basically provides you autocomplete, IntelliSense, documentation, all of that behind the scenes. And GraphIQL is not a single tool for that matter. By that, what I mean is it's an ecosystem of tools. So you have lot of plugins or packages running behind the scenes. For instance, the GraphQL language service, which provides a GraphQL specific service, and you have plugins which provide functionality for each and everything you are doing with GraphIQL. So, and even other tools, not just GraphIQL, leverage those same kind of ecosystem which GraphIQL uses. So GraphIQL acts as a first implementer for all these plugins, and once GraphIQL has implemented them, the other tools also follow pace. Another tool I want to mention here is there's Playground from Prisma team as well. So that's also pretty good. In fact, GraphIQL and Playground has joined forces recently. And then there is GraphIQL Explorer. So if you have a schema and if you don't have developers who understand GraphIQL, or you are starting off with GraphIQL, or even otherwise, so if you want to have a simple way to define your GraphQL queries and mutation by just checking the boxes and running the operations, GraphIQL Explorer is one such tool where you can just check what you need and then query it. And GraphIQL Explorer will get the data for you or define the queries and mutations for you. Then you have GraphQL Voyager. So we talked about introspection, right? So GraphQL Voyager uses this introspection and basically generates all these data graphs from GraphQL to understand. So this is like a ER diagram, right? So what are various entities? How do they relate to each other? And what are the various fields under those entities? So all of these is provided by GraphQL Voyager. Then you have GraphQL Upload. So you have HTTP file uploads. Similar way, GraphQL also has a way to upload files and documents, but that is not part of the same spec, but rather there is a parallel spec called multipart GraphQL multipart spec, which you can use to upload and download files from GraphQL. Then if you are using real-time updates or real-time changes to your GraphQL server, that's why you have GraphQL WebSockets. So you can GraphQL WS will help you add a real-time update or change feature to your GraphQL servers. You have Apollo Federation, which helps you distribute your data graph across multiple microservices. So each and every microservice can own a part of data graph, and then ultimately the users can see a single graph where you have all these in place. So this is Apollo Studio. It's a proprietary tool, not open source one. So, but still, it provides powerful tooling for GraphQL to explore the schema, to view the change logs, and do all of the things with GraphQL. I added Gatsby here because it pretty much uses the power of GraphQL to talk to multiple other plugins. So you define all of the things, all of the data in GraphQL, and that's what Gatsby uses underneath to do all of its operations. You have OpenTelemetry, which you can use to do instrumentation and tracing, distributed tracing of GraphQL resolvers. So if you are using GraphQL server and you are using multiple microservices and you want to trace the GraphQL request across multiple microservices, so you can do it all through OpenTelemetry. So recently it has been merged from OpenTracing and OpenCensus. Initially they were two separate projects, but now it has been merged and there is a new GraphQL spec out there. I will provide all these slides for you. You can actually go through all of this later as well. Then you have GraphQL Faker, which is basically a tool which helps you mock data based on your GraphQL schema. So if you have a string, it will provide you a way to expose all the string types. So if you have an integer, it generates random data which you can use rather than having to define all the data in your database and then working through it. So rather you can just say, okay, this is the type of data which I want, and just get it for me, and it will go and generate all the data for you behind the scenes. For instance, yeah, that's what we are seeing here. So Ivan and the pet image. And yeah, I would like to probably stop here. So this is how a typical GraphQL workflow looks like. So you do evaluation and research, get your boilerplate ready, you put together your data graph and documentation, you deploy it, mock it. So there is a typical workflow which you want to use with GraphQL. I have outlined this in the blog which I wrote, so you can have a look at it as well. I know I went at a huge pace. Probably if you're a beginner, you might not have understood everything, but it's a start. So you got introduced to GraphQL. But if you are not using JavaScript or TypeScript, almost all the tools I talked about today was related to JavaScript or TypeScript, right? There are other tools, similar tools in other languages as well. And if you want to have a look at it, you can go to graphql.org/code. And depending on the language you use, whether it is Golang or Rust or Java, whatever it is, so there are tools available which does the similar things, but may not be exactly same, but it does a lot of stuff for you. So you can go and check it out. And thank you. So this is where you can reach me. So in case you have any doubts, questions, and probably the next time, maybe some other time, we can probably go a bit more deeper into GraphQL. But yeah, thanks for that. Hi, Daniel.
Hey, Vignesh. So thank you so much for that insightful talk. And we already have some questions from the audience. So Marisa asked, is GraphQL for smaller scale project or bigger scale projects? Do you want to chime in on that, on how to approach that in such situations?
Sure. When you are starting off with GraphQL, so GraphQL is meant to be incrementally adopted. So the scale doesn't matter. So if you are in a smaller scale project, you don't need all these tools in place. You just need the minimal number of tools to get started off. And as you scale up, you can probably add more to the ecosystem. So it does cater to all these, architectures as well.
Got it. Okay, so on that note, there's no more questions from the audience.
Thank you. So it was nice meeting you all.
Thank you so much, Vignesh.